Hello there, Mr. Sutton here with the AB Calculus Derivative Extra Practice number 6 solutions. For this one, to take the derivative, we're going to need to use the chain rule. So we have, as the outer function, arcsecant of something. That derivative is going to be 1 over the absolute value of something, of x to the e, times the square root of something squared minus 1. So all that stuff is the outer function. Now for the inner function, we have to multiply by the derivative of x to the e. That's a variable to a constant, so we can just use the power rule. That's going to be e x to the e minus 1. To find this derivative, I'm going to need to use the product rule. So that's going to be u prime v plus uv prime. And let me set up my box and ribbon to help me sort that out. I've got my factors, log base 5 of 2x and sine of 3x. Now for the derivatives, this is log base 5 of something. We have to use the chain rule here. So that's going to be 1 over the something, the 2x, times ln of 5, times the derivative of 2x, which is 2. For this other one, we have sine of something, another chain rule. That's going to be cosine of 3x times a tail of 3, so 3 cosine of 3x there. And now we're going to multiply it back out using the ribbon to put it back together. So let's see here. This is going to be a 2 and a sine of 3x over 2x ln of 5. And we have a 2 there as well, although actually these 2's are going to cancel, so I guess we don't need to include both of those 2's. We'll just leave them out. And then going the other way, we've got a 3, we have a log base 5 of 2x, we've got a cosine of 3x in whatever order you want to put those together. There we go. And this is done. Don't have to simplify. For this one, we're going to be using the chain rule to take the derivative. So our outer function, we have tan of something. Derivative of that is going to be secant squared of something, of 4e to the x cubed. Next, we have to take the derivative of 4e to the x cubed. That's 4e to the something, thinking about this as another chain rule. Derivative of that is just 4e to the something, to the x cubed. And then we have to take the derivative of x cubed, which is 3x squared, and then we're done. On this problem, at some point we're going to have to use the chain rule, but not as much of a chain maybe as you might have thought. The e and the first ln here actually do cancel out, so you can rewrite this as y equals just ln of 3x plus 2. And now this is ln of something, so taking the derivative of the outer function, we've got 1 over something, 1 over 3x plus 2. Now we multiply by the derivative of the 3x2 of the something. That's going to be 3, and we'll just put that in the numerator. To take the derivative of this function, we're going to go ahead and use the quotient rule, u prime v minus uv prime over v squared. So setting up the box and ribbon for that one, we have the numerator, x squared plus 2 quantity cubed, and denominator, x minus 4. Taking the derivatives of those, this first one is a chain rule. This is really a something to the third power situation. So that derivative is going to be 3 times the something squared, 3 times x squared plus 2 squared. And then we multiply by the derivative of the x squared plus 2, which is 2x. And over here, this one's a little bit easier. Derivative of x minus 4 is just going to be 1. At this point, to put it all together, we're going to use the ribbon. So we've got 3 parentheses x squared plus 2 squared, 2x times x minus 4, all of that in the top of a big old fraction. And then going the other way, we're going to be subtracting x squared plus 2 to the third power times 1, all of that. And then downstairs we've got v squared, so x minus 4 quantity squared. On this one, I'm going to have to use the chain rule to take the derivative. My outer function is 5 to the something. Derivative of that is going to be 5 to the something ln of 5, so 5 to all this stuff with an ln of 5 out front. Next, we have to take the derivative of arcsine of 2x squared. Well, this is an arcsine of something kind of situation. So the derivative of that is going to be 1 over the square root of 1 minus something squared. In this case, the something is the 2x squared in there. And then finally, we need to multiply by the derivative of 2x squared, which is just 4x. To take the derivative of this expression, I'm going to first rewrite things so that I can use the power rule a little bit more easily. So this middle term here, I'm going to rewrite this as negative 4/5 times x to the negative 5th power. So just moving that x upstairs with a negative exponent. And this whole last term, I'm going to write this as 3x cubed, the whole thing raised to the 1/2 power. All right, let me take the derivative now, just using the power rule and a little bit of a chain rule at the end. So for this first one, we've got 12x squared. For this middle one, we have negative 5 times negative 4/5. Well, the negative 5's essentially cancel. You've got plus 4x to the negative 6. And then for this last one, this is something to the 1/2. Derivative of that is going to be 1/2 something to the negative 1/2. So 1/2 3x cubed to the negative 1/2. But don't forget to multiply by the derivative of that inner function. So we're multiplying by 9x to the second power. For this problem, taking the derivative of a product, I'm going to have to use the product rule since I can't really simplify this away. So I've got u prime v plus uv prime and box and ribbon time to help me out with the organization. I've got my two factors, e to the 3x and sine of 5x. And now I have their derivatives, both of which are going to require a small chain rule. So for this one, we have e to the 3x times the derivative of 3x, so 3e to the 3x. This one, I've got the derivative of sine, which is cosine of 5x, but we have to multiply by the derivative of 5x, so that's 5 cosine of 5x. Using the ribbon to multiply it back together, we have 3e to the 3x sine of 5x for the u prime v part of this. And then we're going to be adding e to the 3x times 5 cosine of 5x for the uv prime part. And that's it. To take the derivative of this expression, since we have a variable in both the base and the exponent, we're going to have to use logarithmic differentiation. So we'll start by taking the ln of both sides. So we've got ln of y on the left and ln of all this stuff on the right. Now that's going to pop out the exponent. So we're going to have secant squared of 5x down on the ground level here, and then we're going to have ln of the base, or actually just ln of the base, which is ln of x, so ln of x, a lot of ln's there. So now we're going to implicitly differentiate both sides. On the left side, we've got 1 over y times dy over dx. We need that because y is an inner function of x, so we need the chain rule there. On the right side, we're going to use the product rule. So let me set up my box and ribbon. I've got my two factors. We have secant squared of 5x. We'll put that in the upper left here. And ln of x is the other factor. Now we'll take their derivatives, and these are both going to be chain rules, so a little bit of work on this end. For this secant squared of 5x, our outer function in this chain rule is something squared. So derivative of something squared is going to be 2 times the something. So that's 2 times secant of 5x. Now we have to multiply by the derivative of secant of 5x itself. That was the something from before. So this is going to be secant of 5x tan of 5x. And then finally, finishing off the chain rule, we multiply by the derivative of 5x, the innermost function, and that's 5. Over here, we have derivative of ln of x. Well, this is ln of something, so derivative of the outer function is going to be 1 over the something, 1 over ln of x. But now we have to multiply by the derivative of this inner ln of x, which is just 1 over x. And now we'll use the ribbon to put it back together. So we've got, let's see here, a 2 times a 5 should give us a 10. Secant, I guess you could call this secant squared if you wanted to, tan of 5x, ln of x. We'll see how much I actually simplified it. Well, not a whole lot. I didn't simplify it at all. Probably playing it safer that way. Going the other way, though, we have secant squared of 5x, and I'll just simplify this a little bit, over ln of x and x in the denominator. There we go, just compressing things a little bit. Now we're not quite done because we still need to get dy over dx by itself. To do that, we'll multiply both sides by y. So I'll have y times all this stuff on the right side in a big parentheses. So nothing changed except for this little y outside here. And they didn't say we had to get this in terms of just x, but if we did, we could replace this y down here with what y equals, the ln of x to the secant squared of 5x. So this right here is an alternate final answer just in terms of x. For this problem, we're taking the ln of all this stuff and asking for the derivative of this. Now, at first glance, this looks like a chain rule with more chain rules inside of it. We can definitely simplify this, though. Cosecant squared and cotan squared are part of a trig identity. You might remember 1 plus cotan squared equals cosecant squared. So if I just take this identity and I subtract cotan squared to the other side, I end up with the stuff inside this being equivalent to just 1. So I'm going to replace that and have ln of 1 is my function. Now the ln of 1 is 0, but even if it weren't, ln of a constant is just a constant. So if I'm taking the derivative of that, no matter what this really comes out to, the y prime of this stuff is just going to be 0. For this problem, since I can't really isolate y, I'm going to go ahead and use implicit differentiation to find the derivative. So going from left to right, tan of x, that's really, if I take the derivative of that, that's going to be secant squared of x. And now this next one, 6xy, that's going to be a product rule. So let me get out the box and ribbon here. So my two factors, I'm going to call one of them negative 6x. I'm going to build the negative into this so I don't have to worry about it later on. And then y will be my other factor. Derivatives of those, we're going to have negative 6. And this is going to be 1 dy over dx. Whenever we take the derivative of y, since it's considered an inner function of x, that means that we have to multiply by the derivative of y, which is just dy over dx. So multiplying this out now with the ribbon, we've got negative 6y minus 6x dy over dx. So again, if you've got the negative in here, it's already going to be built into everything when you multiply this out. And then we've got the other side of the equation now, 4y to the 6th, that's going to become 24y to the 5th times dy over dx. Still got to use that chain rule. At this point, I'm going to get everything with a dy over dx on one side of the equation and move everything else to the other side. So this negative 6x dy over dx, that can stay on the left. 24y to the 5th dy over dx, I'm going to subtract that over to the left side. And secant squared of x, I'm going to subtract that over to the right side, along with this 6y, which I'm going to add to get it over to the other side. At this point, now that I have only dy over dx terms on the left, I factor out dy over dx, leaving me with negative 6x minus 24y to the 5th inside that parentheses. And then to get dy over dx by itself, I simply divide by this parentheses. So I have all the stuff that's currently on the right side divided by all the stuff in that parentheses, and that's going to be my dy over dx.